Hey everyone, welcome to The Explainer. I'm super excited to dive into a topic today that's frankly absolutely essential if you're anywhere near industrial automation. Whether you're an engineering student, a PLC programmer, a seasoned electrician, or a maintenance engineer, you know mastering this is just non-negotiable. Today we're going through the ultimate VFD Parameters master guide, and we're going to make these complex configurations crystal clear. So let's kick things off with a quick question. Imagine you've just unboxed a brand new variable frequency drive, a VFD. You get it wired up, connected to the motor. What happens right after that connection is made? Do you just hit start and walk away? Absolutely not, right? If you skip configuring the drive, you aren't just risking that the motor won't turn on. Without dialing in the correct parameters, that motor can immediately throw a fault, run terribly inefficiently, or, worst case scenario, suffer permanent mechanical or electrical damage. And man, nobody likes the smell of burning expensive motor windings. You just can't treat a VFD like a simple plug-and-play gadget. So here's the game plan for today. We'll start with the VFD brain and basics, move into essential control and protection, cover applications and communication, look at some common mistakes, and wrap up with DEVI automation solutions. All right, section 1, the VFD brain and basics. Let's set the foundation. To really get the hang of this, we need to look at what a parameter actually is. Think of parameters as the actual brain of the drive. Straight out of the box, a VFD is basically a blank slate with some generic factory defaults. The parameters are the specific rules you punch in that tell that brain exactly how to handle, drive, and protect the specific motor it's wired to. Without those rules, the drive is essentially flying blind. So, where do we find these rules? Well, from the motor's DNA, the nameplate data. The absolute first step for safe operation is getting right up to that physical metal plate on your motor and entering those exact values into the VFD. You've got to tell the drive the motor's power in kilowatts or horsepower, its rated voltage, rated current, the frequency, 50 or 60 hertz, the RPM, the number of poles, and the power factor. This data tells the VFD exactly what kind of beast it's dealing with. Once that DNA is loaded in, we establish the basic operational limits. These foundational VFD parameters set the boundaries for how fast or slow the motor is even allowed to spin. We're talking maximum and minimum frequencies, the base frequency, and capping the output voltage and current. Basically, this is how we lock in precise control over the motor's speed and torque for whatever specific application we're working on. Moving on to Section 2, Essential Control and Protection. This is where we unlock the superpowers. Look at the dramatic difference between a traditional direct online setup and a VFD. Without a VFD, hitting full power gives you a hard start. That's a violent mechanical shock and a huge spike in current that just wreaks havoc on belts, gears, and bearings. But by dialing in the acceleration and deceleration time parameters on a VFD, we get a beautifully smooth soft start and soft stop. The motor ramps up and ramps down perfectly. Honestly, this alone extends the life of your pumps, conveyors, and fans by years. So how do we actually tell the drive how fast we want it to go? That's where speed control parameters come in. You can set it to local control, meaning an operator just pushes buttons right on the VFD keypad. Or you step it up to analog control, using an external dial or potentiometer, running on 0 to 10 volts or 4 to 20 milliamps. And for the fully automated systems out there, you can configure the drive to take advanced commands straight from a PLC, an HMI touchscreen, or even a massive SCADA network. Now this brings us to one of the VFD's coolest features, acting as an invisible shield. By setting the motor protection parameters, the drive constantly monitors the whole system. If it senses a mechanical jam, boom, it triggers overload or stall protection. It's constantly watching for overcurrent, overvoltage, undervoltage, and ground faults. It even gives you thermal protection so the motor doesn't overheat and literally melt its own windings. It's stepping in to stop catastrophic failures before they even happen. To get the drive talking to external devices, we configure the I/O, or input/output parameters. Digital inputs handle your basic on and off commands, like a switch telling a conveyor to start, stop, go forward, reverse, or jog. Analog inputs and outputs, on the other hand, handle variable data. That's the stuff that lets a VFD precisely control a water pump based on live pressure feedback, or tweak an exhaust fan based on temperature sensors. Section 3, Applications and Communication Setup. Let's connect this to the real world. Modern factories are obsessed with data, right? By configuring communication parameters, we're basically teaching the VFD the native language of the factory floor. Whether you're running a traditional RS-485 serial connection with Modbus RTU or a high-speed Ethernet setup using Modbus TCP, these settings let the VFD stream its data seamlessly back to your main PLCs and SCADA networks. Total facility monitoring, right at your fingertips. The big takeaway here is that when you master these parameters, you're mastering the literal heartbeat of global industry. Proper VFD configuration is the backbone of municipal water treatment plants, massive commercial HVAC systems, factory conveyors, food processing lines, and even smart agriculture irrigation. Get this, optimizing pump parameters with a VFD can actually cut energy usage by up to 50%, and every single one of those applications relies exactly on the parameters we're talking about today. Okay, Section 4, Common Mistakes and Best Practices. Let's avoid some pitfalls. Let's look at where things usually go wrong, because a tiny typo here can turn into a massively expensive headache. Entering the wrong motor voltage or frequency, that leads straight to motor damage or just awful inefficiency. Messing up the current setting, you're either getting annoying false trips that shut down production, or you'll have zero protection when an actual fault occurs. If you set your deceleration time way too fast for a heavy load, you can trigger an overvoltage fault or literally tear the mechanics apart. And hey, if you've ever hit start and the drive just stares at you doing nothing, yeah, you probably selected the wrong control mode parameter. To avoid all of that mess, just stick to these pro tips. Number 1, always double-check the motor nameplate data. Measure twice, cut once, right? Once everything is humming along perfectly, back up your parameters and enable password protection so nobody accidentally bumps a setting. If you're commissioning 10 identical conveyors, save yourself a headache and use the parameter copy feature. And finally, do regular testing and keep really meticulous documentation of your settings. Trust me, future you will be very grateful. So, if we were doing a quick mental demo right now, the checklist is pretty straightforward. Step 1, input that vital motor voltage and current from the nameplate. Step 2, establish your frequency and RPM boundaries. Step 3, dial in those smooth acceleration and deceleration times for that nice soft start. And step 4, always perform a controlled run test at a low speed before handing the keys over to production. Finally, Section 5, DEVI Automation Solutions, your expert guide. As we've seen, the payoff for proper configuration is huge. It guarantees safe operation, it maxes out your system's efficiency, significantly slashes energy costs, and seriously extends the life of your heavy equipment. But pulling that off on a massive industrial scale, you need a partner who knows this technology inside and out. And that partner is DEVI Automation Solutions. Their philosophy is beautifully simple. Smart technology, powerful solutions, better tomorrow. They really are the premier experts when it comes to integrating advanced control systems into modern infrastructure. DEVI provides an incredibly comprehensive suite of services too. They don't just do expert VFD installations. They tackle complete industrial and home automation projects. From programming complex PLC, HMI, and SCADA systems to integrating bleeding-edge AI and the industrial Internet of Things. Whether it's smart manufacturing, smart agriculture, solar energy setups, or custom control panel design, the team at DEVI brings complex engineering projects to life. Which leaves us with one final thought. You now know the immense power hidden inside those VFD parameters, and you know the exact experts who can help you deploy them. So, are you ready to stop guessing with your machinery and start building a smarter, more powerful tomorrow with DEVI Automation Solutions? If you found this explainer helpful, please hit that like button, let us know your thoughts down in the comments, and be sure to subscribe to the DEVI Automation Solutions YouTube channel. You can reach out to them directly at deviautomationsolutions@gmail.com for your next big project. Thanks so much for hanging out with us, and keep learning.